Howdy folks, welcome back. So in this video, I'm just going to go through the practice quiz and again show you how I go about solving problems. Again, I recognize it's by no means the only way, and in some cases it might not be the way that works best for you. If you have another way of solving these problems, again, as long as you arrive with the correct solution at the end, you don't necessarily have to do it exactly the way that I do it here. But if you're curious where to start, this kind of shows you where I go about starting there. All right, so the first problem is dealing with stating the dimensions, so the number of rows and columns of the matrix produced by different operations. So you don't need to solve these, although if you do solve them, that kind of gives you the answer. You can just look at the rows and columns of your solution there, but you don't necessarily have to do that for the problem there. Again, I'm just looking for the dimensions, so the rows and columns there. All right, so in this case, we have a 2 by 2 matrix. So you have 2 rows and 2 columns. And we're adding another 2 by 2 matrix. All right, so when you're adding or subtracting, the two matrices need to have the same dimensions. So they need to have, both matrices need to have the same number of rows and columns. All right, and then your sum or difference is going to be a matrix that consists of the same number of rows and columns of the two matrices that you're either adding or subtracting together. All right, so in this case, my result is going to have 2 rows and 2 columns. All right, so you can just state 2 by 2, or again, the number of rows and the number of columns. All right, so when you're multiplying two matrices, so here we have a matrix that is 2 by 2 again, and here we have a matrix that is 2 rows and 1 column. All right, so when multiplying two matrices, the two inner dimensions need to be the same, so two inner dimensions need to equal one another, and then your result is going to be a matrix that consists of the two outer dimensions. So in this case, when I multiply these together, I'm going to end up with a 2 by 1 matrix. Oh, 2 by 1. There we go. Or again, a matrix that consists of 2 rows and a single column. All right. Next question here is dealing with finding the inverse of a 2 by 2 matrix. So again, I'm going to stick with a 2 by 2 on the quiz as well as on the exam there. Because again, we have a nice little kind of formula that we can use to find the inverse here. All right, so the first thing we need to do is we need to find the determinant. So I'm just going to call this matrix A. So we need to find the determinant of our matrix. All right, so to find your determinant, you're just going to multiply the entries along the main diagonal and then subtract the product of the matrices along your secondary diagonal. All right, so you have negative 2 times 5 is going to be negative 10. And then 3 times 4 is going to be 12. So we have negative 10 minus 12. So that's going to be negative 22. All right. And then to find your inverse, so A inverse, you're going to swap the entries along the main diagonal. So we're going to swap 5 and negative 2. All right, so here again, along the main diagonal, we have negative 2 and 5. So we're just going to flip those around. And then you're going to change the sign on the entries in your secondary diagonal. So we have negative 3, negative 4, instead of 3 and 4 there. All right, and then you're going to divide each entry by your determinant. All right. And then we can just do some simplifications here. All right, so you have negative 5 over 22. You have negative 3 over 22. All right, so negative 4 over 22, so that has a common factor of 2. So again, we have negative divided by a negative, so that's going to end up being positive. We're going to have 2 goes into 4 twice, and 2 goes into 22 11 times. So we're going to have 2 over 11. And likewise here, we can do a similar thing with negative 2 over 22. So again, we have a common factor of 2. So that's going to be 1 over 11. All right, and that is going to be my inverse there. All right, finally, the last problem here is using the matrix inverse to solve a system of equations. All right, so here we have my matrix A consists of the coefficients of my system of equations here, and A inverse is given there. So again, I'll give you the inverse for this problem here. All right, so to use the inverse to solve the system, you're just going to take your inverse and multiply it by the column matrix made up of your constants there. All right, so we have -4, 1, 2, 7, -1, -4, -1, 0, 1, and we're going to multiply that times my constant there. All right, so again, to multiply two matrices, you're just going to march across the rows of your first matrix and down the columns of your second matrix. So in this case, the column, I guess. All right, and you're going to multiply entries as you go, and then you're going to find the sum of all those individual products. So here we're going to take -4 times -2 plus 1 times 5, and then plus 2 times 4. All right, so that's going to be my first row, so that's going to represent my x value. All right, so then for my second row, you're going to use the second row of your matrix, and again, the single column here, so you have 7 times -2 plus -1 times 5 plus -4 times 4. And then finally, for my third entry, we have -1 times -2 plus 0 times 5 plus 1 times 4. All right, so then it's just a matter of doing the arithmetic here. All right, so when I take -4 times -2, 4 times -2, that's going to be 8 plus 1 times 5, so that's going to be 13 plus 2 times 4, which would be 8 again. So 13 plus 8 is going to be 21. All right, and then we go on to the second row here. So you have 7 times -2, which would be -14 plus -1 times 5. So that would be -19 plus -4 times 4. It's going to give me -35. And then finally, for the last row here, we have -1 times -2 plus 0 times 5 plus 1 times 4. And that's going to give me 6 there. All right, so I'm fine if you leave it like this, but technically, I guess you'd want to write down what the different variables are here. So again, x represents our first row, y is represented by our second row there, and z is represented by our third row. All right, so again, that's how I go about solving the problems. Again, I recognize it's by no means the only way, and in some cases it might not be the way that works best for you. But if you're curious as to where to start, that just kind of shows you where I would start there. All right, thank you very much. Have a good day. I'll talk to you later. Bye now.